All right, everybody. We're going to get started. I think everybody's here that's going to be here after lunch. So my name is Tom Markiewicz. I'm a developer advocate with IBM. And today I'm going to talk about an introduction to serverless computing with Swift. And so first, let me just kind of introduce myself a little bit, give a little context behind this. As I said, I am a developer advocate at IBM. I've been there for a few years. My background, though, has been working in startups for about the past 12, 13 years before I went to IBM. And at IBM, I've been working mainly on Watson, artificial intelligence, all the machine learning applications, specifically with natural language processing and Watson Discovery, which is kind of like a intelligent search product. And I also recently wrote a book on getting started with AI that if you go to that link, you can download it for free. So we only have 20 minutes today, so I'm going to try and cover a lot of ground quickly. But first off, like show of hands, how many of you have actually had any experience with serverless? Okay, so a handful. Maybe some of you probably have more experience than I do. But a lot of this came from a journey that I took trying to solve some specific problems and just in the process learning about how to use the technology and where to use it. And that's kind of what the focus is going to be. So kind of an overview, what is serverless, just what's it good for, what are the use cases, get you thinking about where you could use this in your applications or in your business, in your work. What platforms are available, so there are companies that allow a hosted functions as a service. Then I'm going to specifically talk about just one of them, Apache OpenWhisk, and then show some code. So first, I just want to talk about a little story about how I got to even being interested in serverless. So one of the things, the last startup that I worked on, what we did is we built a web application. It was a service that would go out and it would aggregate financial information. So let's say you were an investor in Apple and you didn't have enough time in a day to read all 300 articles that are written every day on Apple. So what we did is we had a service that would go out, it would aggregate all the content for every security that we could find. And then what we would do is we would summarize it, package it up, and then deliver it to our customers. And so one of the products that we had used at the time was from a company called Postlight, and they made this service called Mercury. And some of you maybe have used it. They make a really cool Chrome plugin that if you see a web page and there's like tons of ads and the formatting's crappy, you can just click on the Chrome plugin and it strips everything away, and it's just a really nice web parser. And so about a year ago, so after we had kind of shut down that company, long story there. But I had started again on using a lot of the code on a side project that once again would be, taking content, parsing it, stripping out everything, and then I was doing stuff with this, just the actual content. And what happened was that Mercury was running this as a hosted service for anybody to use, and they finally got to the point where they said, hey, you know what? This is just not a moneymaker for us. The resources are constrained. So instead of us providing this service for free to everybody, we're instead going to open source it. And one of the things that they did, if you go to their GitHub repo, is that they said, you know what, you can either run the server, host all this code yourself, expose an API, and hit the API just the same way that you would before, or here are the instructions on how to deploy this onto AWS Lambda, and once you deploy it to AWS's Lambda, which is their serverless function as service, you can then take the URL that will get exposed for you, and you can just drop that into your code, and boom, you have exactly what you had before. So now, instead of having to go through the process of building my own server and running a separate instance just for this one specific application that I had, instead I could deploy this on AWS Lambda and and I think in terms of pricing, you have to get into huge amounts of scale, and hopefully at the end I'll have time to talk about this. But basically, I'm going through now just a little side project that I have, but somewhere in the order of about 500,000 to about 1 million requests to this function a month, and it's completely free. Okay, so even if you're able to spend the time and put this on a $5 server at DigitalOcean or anywhere, you could still do this for free. So I thought this was a really interesting use case, and hopefully as we go through this, you can start thinking about where you could implement serverless in your own applications. So probably most of you understand this, that obviously serverless still uses servers, but what we're talking about here is really looking at not one specific technology, but instead looking at more of the concepts that are packaged together to create what we call serverless. So servers are obviously still executing your code, but instead of dealing with the infrastructure, managing it all, you get to just, as a developer, you just get to focus on the code itself. So you're writing functions that do specific actions, and then they run in stateless containers, okay? So you get to focus, like I said, on what you're building, your use case, the business that you're running, the application, how it works, and just thinking about specific things that you can outsource and then start to take advantage of being very elastic, being very scalable, and being very inexpensive when you take into account that you're not dealing with that infrastructure. So one way to look at this is, when you think about if you were, choosing a car, you can look at it in terms of, do I want a manual transmission? I can have more control, maybe potentially a little bit more maintenance, or do I want an automatic transition where I just need to get to point A to B? I don't want to think about maybe internally what's going on. I know that's a little bit oversimplified, but if we look at it in terms of a scale from first control, right? So functions are going to give you less control. We move along the path of containers, VMs, and then you get to this, running the bare metal. That's the spectrum, less control versus more control. When we talk about maintenance, same kind of thing, way to think about it. You're going to have way less maintenance when you're dealing with serverless functions, and then the spectrum goes down until you get to bare metal, and you're actually then having to deal with everything yourself. So I touched on a few of these already, but why do you want to use serverless? So I mentioned scalability. If you are unsure of how much resources you're going to need, instead of provisioning servers in advance that are going to sit idle, you can instead use serverless functions that are only going to be used when they're called on demand. And typically, if you're using one of the providers that offer this, what you're going to do is you're going to be paying for the compute time. So when a function is called, how long it takes it to run, and we're talking usually like milliseconds, max, and how much memory would be used to run that function. And those are the two drivers that would affect how you pay. So that gives you this nice pay-per-use model that you're not paying for overcapacity. You're able to scale, and it gives us a lot of the promises that have been made over the years for cloud computing in general. I find that serverless kind of gives you that in its purest form. Okay. So what that can then cause is a decreased time to market, event-driven scenarios. So being able to just focus on when things happen. Is there a particular action that occurs, and then I want these functions to run. And then it also gives you the opportunity to offload, some CPU-intensive tasks. So I'm going to show a little, next, kind of just an example or a case study where, maybe we would use something, a different type of, an AI service like visual recognition, and we don't want to be waiting for that to happen. We don't want to be paying for the resources, and so we can offload that to another cloud service. So I've been talking about these serverless functions. Here's an example of just what one looks like in its most basic form, right? We have a function, we're going to pass it parameters. In this case, we're just going to pass it a name and a place, and this function just returns hello, name from place. That is the most basic serverless function that we can get. And in terms of what you'll see when you start diving into this, and hopefully today I'm providing you just kind of like the impetus to get started looking at this, but you're going to have triggers, whether you call it yourself in your application or it is some kind of external event that is triggering this. But the action is the main thing, right? Each action, we're going to be looking at an input and then an output. And then you're going to be getting this JSON back and being able to do something with it in your application. So some more kind of use cases if we want to look at this. I'll give a specific example next, but one thing that's obviously pretty relevant here is if we look at having mobile backends. Being able to, once again, instead of standing up a whole server-side web service and building out your own APIs to do specific functions within your application, you could use serverless to basically outsource that and once again not maintain the servers, but kind of have this scalable backend for that. Another thing when you talk about web application backends, being able to call and basically create your own APIs for specific things that need to occur in your application, and being able to define these endpoints using serverless to just call them, and once again not having that resource. Another part of this, data processing. So this is where the scalability really comes into play. If, for example, that you need to do a lot of image processing, a lot of maybe tasks that do occur maybe in batches or maybe on a frequent enough basis, but you don't know how often it's going to happen. This is one area where you can use serverless to call that function, do the work, it'll return it to you, and it will have this elastic scaling as you need it. And another part that's interesting, and this is especially true when you start looking at some of the hosted platforms out there, instead of setting up complicated or extensive cron jobs on a server, you could take these tasks and you could schedule them and offload a lot of this processing to serverless without once again having to maintain that. So one specific example that we can look at here is if we were building a visual recognition app. So one of the things that I worked on a lot last year, IBM had a partnership with Apple, and what we did is we took our Watson visual recognition and we combined it with Apple's Core ML, and we were able to run visual recognition on the edge. So being able to identify stuff, any kind of images when you don't have an internet connection. And that's a lot of fun, but sometimes you don't need that much processing. Maybe you want something a little bit simpler, and maybe you don't want to build all that into your application. So here's an example, is if let's say you had an application and you wanted to take a picture, you didn't know what this dog was, this could be all text-based. You could send a picture, have a function that would call visual recognition service, and this could be like we do at IBM, AWS, Google, they all have a version of this, but being able to run that, identify the image, get the classifications back, and then possibly run another function, both returning what the actual picture is, but then also you could chain them together and go off and maybe get some pricing information from a pet store or some other product information. And what you're getting back is, once again, it's this idea of input versus output. So here's this input of an image, we send it to a visual recognition service, and it's telling us, okay, this is a specific type of dog, more general, dog, animal, and that's basically, just kind of a simple example, but I wanted to, show some things to kind of get your ideas flowing. As I mentioned, there are vendors that offer functions as a service. So, IBM does this, AWS, Azure, Google Cloud, Oracle has one, there's a few other ones. I think Lambda was the one that came out roughly first around maybe 2014, and then IBM, Azure, Google, these were all maybe like 2016. The one thing, obviously, since I work for IBM, we sponsored and then open sourced Apache OpenWhisk. And so basically, what's nice about that, we have a cloud service that we have that you can use, but what's nice about OpenWhisk is that you still have the ability to use a cloud provider, but you can also not use a cloud provider and run this in Docker containers and not have to rely on a cloud provider itself. But if you want to, you do have that ability to do it, and there's some additional benefits of that. Specifically, if you use one of the cloud providers, you do get the web GUI to be able to go in and manage this. If you much prefer the web GUI, I'm more of a command line person. I'll kind of show you both in the code here, but it does give you that option if you are using these cloud providers to get a little bit of both. So one thing that OpenWhisk provides is a nice CLI tool. I was initially thinking I was going to do live coding, and then I realized that's a bad idea on a 20-minute talk. So I hopefully you'll be able to read these. If not, I have a link to the repo at the end. But I swapped out it last night for screenshots. But basically what I'm going to show you real quick with the few minutes I have left is this is a serverless function written in Swift. I wrote it in 3 different languages, and all it does is it's going to take an input of a name, and it's going to say hello name, and if not, it's just going to, if you don't pass in any name as a parameter, it's just going to write hello stranger, okay? Same thing in JavaScript, same thing in Ruby. So basically, what I'm trying to just illustrate here is that you do have this ability to pick the language you want. Right? So the title of this talk is Intro to Serverless with Swift, but really it's straightforward enough. Pick the language you want, and you can run it as serverless. So if we look at this from a command line, we go through, the first thing that you would do is say whisk action create name of the function, in this case hello, and then the name of that file. And then it's going to say we created that action. Okay? So then we can say whisk action list, and it's going to actually show all the functions that we have available. And in this case, I am connecting to IBM's Cloud Function Service, but you're going to have similar functionality with any of the providers. So just as a reminder, this is what our code is down at the bottom. So this time I'm going to run it, whisk action invoke hello, and it's going to return that greeting hello stranger. But if I do the same thing this time, and this time I'm going to pass a parameter of name 360IDEV, and this time you can see it's returning this JSON, and it's giving us this greeting, hello 360IDEV, okay? So this is, once again, really basic example here, but hopefully you kind of get the idea of how straightforward this is, and very simple. So you could get more complex with this, but once again, it's still, I'm going to write a function, I'm going to write a little bit of code, I'm going to create this function, then I'm going to invoke this function, get back JSON, do whatever I want with in my code. And so same kind of thing if we use this within, if we look at the web app for these same functions, you can see my hello function. It can tell you how much of the memory resources that it's kind of being allocated to. You can look at the code. You can see the activations that happen each time I invoke that. And then getting different amounts of just kind of information on the runtime, what languages you're using. I'm pretty sure all the providers support Swift, Ruby, Java, JavaScript, and I think Python. And so basically, just kind of to wrap this up, if you do want to get started, obviously I like OpenWhisk and IBM's Cloud Functions because I think it kind of gives the best of both worlds in that you have the provider if you want to do it as a service, if you want it hosted, but you still have the ability that you're talking about something that is completely open source and with the Apache Foundation, and it's Dockerized, so that you can use this however you want. Another interesting thing, I didn't really have time here, but as a jumping off point, if you want to play with this more, is there is a serverless application framework called serverless.com. And it much more in depth in terms of building out more complex ways of interacting with your application, and a lot more details there on each individual language and going a little bit further. And so this is my contact information. Feel free to reach out. I'm going to try and get the slides up later into this GitHub repo, but all my contact information. Feel free to reach out. I'll be around also the rest of the conference. I think we're cutting it right at the end here, but if you have any questions, I'll be up here for a few minutes, be able to talk to anybody with anything you might have. Okay.